Hi guys, welcome back to Pipeline versus YouTube channel where curiosity meets the code. Today we'll be discussing about how to create an interactive geometry calculator. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions. So I can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code, starting with importing the necessary libraries, which includes Tkinter as TK, which is commonly used for GUI operations, and we have Tkinter import TTK, which is provides the access to the themed widget set, and we have imported math, which provides access to mathematical functions like pi and tan, etc. And also we have import random, which includes the function to generate the random number. So let's see an overview of the programs, which includes a main class of math formula apps, and then followed by a method under which we have init, and also the second method we have setup UI, and then we have calculator, and then area of a circle, then goes on with area of a rectangle. And then if you come down, you have area of a triangle, area of ellipse, square, rhombus, and displaying the results. That's an entire method. And then execution part. So let's see firstly important methods. So starting with init. So, firstly, class math formula app just defines a class of math formula app to encapsulate the application logic, and we have def init self comma root. This defines a constructor with self representing the instance of the class and the root as the main application window. And we have self dot root is equal to root and self dot root dot title as math formula demo. This stores the root widget and sets the title of the main window to math formula demos. And we have self dot formula is equal to area of a circle. What is the like we are calling the method, which will come down later. So everything is given area of a rectangle. If it's clicked, we go on to a different method. Area of a pentagon, we go on to a different method. Creates a dictionary of self dot formulas, mapping formula names to the respective method handles with the class. And we have self dot selected formula is equal to tk dot string var. This initiates a string var object to hold the string values of the currently selected formula from the drop down. And we have self dot selected formulas dot set. This sets the default value of the self selected formula to an empty string. And lastly, we have self dot setup UI. This calls the setup UI method to build the GUI components. Let's move on to the next method. The next method being setup UI. So starting with df setup UI self, this defines a method to set up the user interface. And we have formula label is equal to tk.label self.root and text of select a formula. This creates a label widget that prompts the user to select a formula. And we have formula label dot pack. This uses a pack geometry manager to display the label in the window. And we have formula drop down is equal to ttk dot combo box self root comma text variable is equal to self dot selected formula. And we have formula drop down values is equal to list self formulas dot keys. And we have these are to set the values of the combo box to the keys of the self dot formulas dictionary. And we have formula drop down dot pack. This displays the combo box using the pack method. And we have calculate button is equal to tk dot button self dot root text calculate command self dot calculate. This creates a button labeled calculate, which when clicked will trigger the self calculate method. And we have calculate button dot pack. This displays a button using the pack method. And we have self dot result canvas is equal to tk dot canvas self root dot root width is equal to 400 height 300 and the background will be a light pink. Just create a canvas widget which is rectangular area intended for drawing the pictures or complex layouts. Here it sets with the width of 400 pixel and a height of 300 pixel and a light pink background. And we have self.result canvas.pack. This displays the canvas using the pack method. So let's move on to the next method. So we have the next method of df calculate. So firstly, DEF calculate self defines a calculate method which handles the calculation of the selected geometrical formula. And we have formula is equal to self dot selected formula dot get, which gets the currently selected formula from self selected formula. And we have if formula in self dot formulas check if the selected formula is valid, that is exists in the self dot formulas dictionary. And we have result is equal to self dot formulas formula. This calls the method corresponding to the selected formula and store the result. And we have self dot display results. In results, this calls self dot display result to update the canvas with the calculation of the result. And we have else print invalid formula selected. If selected the formula is not in the dictionary, print an error message. Let's move on. We have the next few methods to calculate the different shapes. So I'll be explaining a few of them. So starting with DEF, area of a circle self, radius 50, area is equal to math dot pi into radius square. And we have returning radius, area. To calculate, this is for calculating the area of a circle using the formula pi into radius square. The radius is hardcode to 50 for demonstration. Next, we have a method to calculate the area of a rectangle. So as you can see, we have the length as 100 with 50, area is equal to length into width, and we are executing length and width and area. So this is complete the area of a rectangle using the formula length into width, and the same goes with the next one, area of eclipse. Again, here also we have A is equal to 100, B is equal to 50, and the formula of mat dot pi into A into B, and then we are returning a value of the area. Similarly, we have area of a square. Again, side and side is given as 80, and the formula is side square. So again, we are returning the side and the area from this method. Next, we have a method to calculate the area of a polygon, and here also a side and side length is also mentioned, and area is calculated with the formula, and it returns the side length, and the area of the polygon. Moving on, we have area of a rhombus. Again, diagonal 1, diagonal 2 is already pre-given the numbers, and we calculate the area by 0.5 into diagonal 1 into diagonal 2, and we return diagonal 1, diagonal 2, and the area value. Next, we have a method to calculate the area of a trapezoid, and we have base 1, base 2, and height given, and area is calculated by 0.5 into base 1 plus base 2 into the height, and we return all the values plus the area which is calculated. And lastly, we have to calculate a method to calculate the area of a pentagon. Again, apotheme and side length is already given. We calculate the area, we display the apotheme and side length and the calculated area of a pentagon. Lastly, we have a method called display results. So we have firstly we have df display result self dot result. So here it defines the display result method which takes the result dictionary from the calculation method and updates the canvas to visualize the result. And we have self dot result canvas delete all. This clears all the previous drawings on a canvas to prepare for new visuals. And we have formula is equal to self dot selected formula dot get. This retrieves the currently selected formula for deciding how to draw the label and the shape. And next we have a if and if else do for each area of a circle, rectangle, polygon, triangle being selected. So we here you can see we have the same amount of commands which are given in each if else loop. So basically we are creating a canvas. So we are giving um, the position of the text, which is the answers to the area, what are the inputs given, and the drawing. So here we are creating a position. So first is self.results.canvas create oval. So this is for area of a circle. We create an oval starting from 50, 50 coordinate and 150 and 150 as the size and outline as blue. And later we have self.result.canvas create text, which is 100, 25, and we have text circle fill blue. And later we have the text, what are the things required, radius, print the radius and fill in black. And then we have the area which is calculated in the particular method, and we also fill it by black. Again, coming back to rectangle, here we have the same thing. Same thing applies for the rest of the shapes. The same code is copied and pasted. Moving on to the execution bit of the program, we have if name is equal to main root is equal to tk.tk, app is equal to math formula app root, and we have root dot main loop. This is the entry point of the application when the script is run directly. It creates a Tkinter root window, initiates the math formula app, and starts the Tkinter event loop, which waits for the events for the user, such as the mouse click or a key presses. So here while going through, I observed an error. Let me just correct it. So as you all guys already know, we have a position for X and like the for the image as well as the text that is going to be side to it. So I've given almost the same values which may overlap. So let me just change the values. So I'm just going to give 200, 50 as a coordinate for the canvas, that is the picture, and then for the text, let it be the same. So if you give the same values, it's going to overlap and you won't be able to read it. So let's see the execution, how the result is. And if then required, we can come back and change the values as necessary. So let's see the output of the program. So as usual, I'm going to go where the file is stored in a .py file. I'm going to copy the name of the .py file, open the command prompt in the same window, python space file name .py. So as you can see, we have to select a formula and we have circle. When you say calculate, we have first the uh, writing and then we have the image. I can just move little more further. I can give 250 for each so that it is more clearer. So you can see the various colors, the background color which we had given as light pink, that is also been there. Thank you so much for watching. If you have learned something from this video, please do like, share and subscribe to our channel.